Welcome to DNSSD. We'll start properly in a few minutes, but meanwhile, please join the Meet Echo. You can use the QR code or follow your usual method.
Oh, yeah, I see it. And
Yep.
let's see, I'm going to grant it. It might kick you out. Let's see what happens. Oh, well, then maybe let me revoke yours, and then I can do it real quick. Grant. Let's do it. Yeah, we can maybe start at like 4 after. I think we don't have a packed agenda.
Yeah.
All right. Yeah, we're also testing if screen sharing works. If only we had a way of discovering screens in this room, maybe a protocol for that. All right, so that works. Cool. All right, I'll revoke it, and then we can do that later. All right, there we go. Yeah, go ahead. Yeah, we don't have a two-packed agenda. We can get started. Yep, all great. Thank you. All right. All right, should we get started?
Yeah, let's do it.
All right. Hello, everyone. We are getting started. Eric, I'm watching you. I'm going to make you take minutes. Oh, cool. Thank you, Eric. Welcome to DNS Service Discovery. I'm David, and this is Chris, and we are your friendly neighborhood chairs. Welcome to IETF115. Next slide, please. So it's Tuesday afternoon. Most of you have probably seen the note well, and all of you have guaranteed at least clicked that to promise that you've read it when you registered. So two parts that I really want to highlight. The first one is the IPR policy of the IETF. Any contributions you make require that you disclose patents that you're personally aware of. So just note that before you talk. And the other one is our code of conduct. We have a clear code of conduct at the IETF, and we want all of our work to be done professionally and nicely. And luckily, that's never been a problem in this working group. So let's keep it that way. Next slide. As a reminder, the IETF 115, just like the last one, has a mask policy. I know that's surprising to some because people aren't wearing masks outside these days, but this is the policy that the community decided on. So please wear a mask, with the only exceptions being that you're actively speaking into a microphone. As per usual, if I see people not wearing masks, we'll do something. Like over there, please put a mask on. All right. So these are some links for folks that see this later. I will do the jabber relaying. If you want to say something in the Meet Echo chat, I can relay it for you. And thank you, Eric, for taking minutes. Much appreciated. Can someone help Eric? So where he's not, no, you're fine? All right, cool, thanks. Next slide. Here are some useful links. Same if you're logging in. I just want to point out why it's very important that you all fill in the blue sheets. Look at how big this room is. This is the first time that we're not in a broom closet and we can breathe. It's amazing. So the more people sign the blue sheets, the bigger the room we get next time. Next slide, please. We have our GitHub organization where two of our three. Ted, did we put the advertising proxy document in GitHub or not yet? Yeah, all right, cool. So two of our adopted working group documents are there out of the three, the third one soonish. And when we adopt future documents, it's becoming our more common way of working on them. It's pretty handy for making sure that people's comments get addressed. Next slide. Speaking of our adopted working documents, quick status update. So the SRP, stateless replication protocol document, we finished working group last call. I think it lasted for a year, so let's try to do better next time. But thank you everyone for the reviews. We had a few comments, they've been addressed. We have a few very minor ones because Ayana provided a review, so let's get those cleaned up, but that shouldn't take long. Similarly, the update lease document, which is required for SRP, the working group last call was completed. There were some comments that have been addressed, and the chairs or shepherds for the documents, we found a few nits that should be fixed before we send it to the IESG, so we expect that to happen pretty soon. And then we'll click the button for RAD overlords to then review. The third document is the advertising proxy, which we adopted last August and hasn't seen a whole lot of love since, but we're going to talk about it some more today. And I think some of the discussion will lead to text changes in the near future.
So while we're on the adopted documents, if anyone's got any thoughts they want to say on SRP or update lease, for example, if you've looked at the issues in the GitHub or you want to discuss them, please join the queue. If not, we'll move on.
All right, next slide. And we also have some individual drafts. So there's the SRP replication one and I am blanking about what TSR stands for, but we're going to be talking about them later, so that's fine. And the zone discovery one, we were talking about it for a while, but it's expired now, so I think that one's on the back burner for a bit. We have a bit of documents that are expired that we just will grab when we need them. Next slide. All right. This is our agenda for today. We have a few conversations proposed by ESCO, interaction between a DNS server and a Discover proxy when they're running on the same thing. Well, I guess I'm not going to read this off the slide. And then we're going to talk about the advertising proxy, which is our working group adopted document. And then we're going to talk about individual drafts that we're considering adopting at some point in the future. Does anyone want to bash the agenda? Or I'll repeat what they're saying. Yeah. So you're saying doing an advertising proxy before the discussion because it makes the slides easier? Does anyone object to that? All right, let's do that. Then I think that's the end of our chair slides, right? Yeah, then Ted, can you come up for that slide set, please?
Okay, so I gave this slide this particular title because when we originally started off, the goal was to have a document that just described what an advertising proxy was. But when discussion proceeded on the topic, it became somewhat clear that what we actually really needed was a document describing the thing that does the advertising proxy function, which also does a bunch of other functions. And so that's why it's poorly named. Next slide. So motivating use case for the advertising proxy. I'm just going to give you kind of an review, but I'll try to keep it brief. The goal, there's two motivating use cases. One is supporting stub networks and the other is replacing MDNS with DNS. And so these motivating use cases have slightly different needs. Stub networks, at least in the current use case that we have for stub networks, the stub network itself is a sort of greenfield environment, and the network it's connecting to obviously is just a regular old network. So we need to support different behaviors on these two networks, and we are not assuming cooperation from the infrastructure. For replacing MDNS with DNS, we probably are going to want cooperation from the infrastructure, so that's a little different. Now the advertising proxy function, which, just to remind everybody, the advertising proxy function is basically serving a DNS zone using MDNS to some link or links. Next slide. So kind of three modes we need to support. One is and these are modes that are happening on a particular link. So this isn't necessarily, like in one installation, you might actually be supporting more than one of these modes. So one of the modes is you've got a greenfield network, so we control the resolver, we can do anything we want with DNS. We don't need an advertising proxy on that link because there aren't any legacy hosts. It's a greenfield network. So we're essentially requiring that they do DNS service discovery through the resolver, which pretty much every host already can do. And importantly, we're requiring that they register themselves using SRP. And by the way, if they want to do service discovery on an adjacent infrastructure link, then we need a discovery proxy for that. So that's one mode. Non-cooperating infrastructure. This is a case where we're on the infrastructure, we're providing service discovery, and the use case for this is, again, the stub network. So in the stub network, we have devices that are on the stub network that are doing service registration using SRP. We need to be able to discover those devices on the infrastructure network. The infrastructure network is not a greenfield network. We have to work with existing hosts, and that means we have to have an advertising proxy. We have to use MDNS to advertise services because we don't control the resolver, so we can't use DNS. The third use case is that we have cooperating infrastructure. So infrastructure is providing a resolver. It's providing service registration protocol somehow. We haven't actually said how that's happening yet, and I don't think this document is where we would say that, but at least in principle, it's providing SRP. We only really need an advertising proxy for devices that don't support MDNS, and I don't really know that there are any such devices, so we probably don't actually need an advertising proxy on this network. We probably do require a discovery proxy because if we're having the nodes on this network do DNS service discovery using DNS and not MDNS, then they're not going to do an MDNS broadcast or an MDNS multicast when they want to discover a service, and that means that the poorly named advertising proxy has to do that for them. So those are the three modes. So next slide. So what we actually need to provide in the document is a little bit more than what we originally set out to provide. And by the way, when I describe all of this, when we originally set out to do the advertising proxy document, we were just going to describe you've got an SRP service and you've got an advertising proxy that's advertising whatever was registered with SRP. And that was a very constrained set of problems. The reason that we morphed out of that is because an SRP server is actually an authoritative DNS server. It doesn't need to do the advertising proxy function. The only reason we need the advertising proxy function is in certain cases, like in a stub network configuration, that's the only way that we can actually deliver what we're trying to deliver, which is service discovery of hosts registering with SRP. So that's why this kind of morphed. And I think it morphing in this way was a good thing, not a bad thing. But obviously, I encourage people to give feedback if they disagree. So what we need, assuming that we accept this sort of larger scope, is we need an SRP registrar. it accepts SRP registrations from whatever networks it's doing that on. It's going to update a DNS zone. So SRP is basically just DNS updates. It's going to update a DNS zone, may update more than one DNS zone. That's something we need to think about. So that's one thing, and that's just keeping an authoritative DNS zone populated with information about services that are available. The second thing we need is an advertising proxy. And the point of that is if we're on a network where we have clients, basically where we don't have control of the resolver, then we need to be able to make this SRP registrations visible somehow, and that the way to make that happen is with MDNS. So that was the original scope of the document, just that one thing. So we've somewhat expanded from that. And then the other thing that we need is a full service DNS resolver. We need this in two cases. We need this both for the Greenfield case, the stub network case, where essentially the stub router controls the stub network and can act as a DNS resolver, and so it can do all of these cool things. And also for the use case where we're doing DNS service discovery using DNS instead of multicast DNS on some future new network that we haven't really talked about yet. So this is a little bit of scope creep, and it may be that we don't actually want to solve that. The reason that it's on there is because since we need it for the stub network anyway, it's not really any different. So, so what a full service resolver has to do is it has to look up names that are non-local using DNS. So like, IBM.com or whatever. Has to provide discovery proxies so that, say you're on the stub network, you can discover devices that are on the infrastructure network. Or if you have a, like if we ever wind up addressing the HomeNet use case again, this would be ideal for a setup in a HomeNet. And it has to be authoritative for the SRP zone, and that's just an authoritative DNS server. So there's no advertising proxy there. It's just advertising DNS, or just answering DNS queries authoritatively for the zones that are maintained by SRP. Next slide. So the current document state actually talks about most of this stuff. Still is called the advertising proxy document. I'm not really sure what to call it, but it talks about the advertising proxy function, the full service resolver, discovery proxy, authoritative server. It's probably not sufficiently detailed at this point. We probably need more text, but it basically covers all of these functions. Next slide. So the questions that ESCO was asking, we had a bunch of questions that were on the agenda, and I lumped these into this presentation because they're actually relevant to this blob, whatever it is. It's not really a discovery, or not really an advertising proxy anymore, but it's relevant to this blob because this blob is doing the thing that ESCO was asking about. So the first question that ESCO was asking, or at least the first one that's on the agenda, is that RFC 8766 is talking about the discovery proxy as an authoritative server, and I'm somewhat contextualizing what ESCO asked because there was a whole bunch of context that came with the question that wasn't actually in the question. But so basically the idea is we've got this thing that's this blob that's both an advertising proxy and a discovery proxy and a DNS server, and we're going to ask a question in a specific zone. And this is something the thread spec does, and that also the discovery broker spec that Stuart and I, mostly Stuart, did a couple of years ago. The discovery broker spec talks about this. The idea is basically you've got a constrained client. You don't want it to do like 1 million queries because queries consume power. And so you want it to ask one question, and based on the answer to that question, it should have the information that it needs to either ask clarifying questions if necessary, but ideally just it's got all the information it needs in order to access some service that it's looking for. And so the idea in the thread spec, it says if you do a query to default.service.arpa, then you will get answers back for SRP, and we don't actually support any local DNS browsing zones, but if there were, then presumably you get answers for those. But so SRP and the discovery proxy, those both come back from the same domain. And so those might be actually the information in those domains might be subdomains of different domains. But when you do the query, the discovery proxy blob, the advertising proxy blob is going to sort of figure out which zones to do queries in order to get answers for you and then return stuff to you. And one of the questions about that is, so RFC 8766 says, when you get a query, you're supposed to wait 6 seconds before you decide that there are no answers. And so in this case, where we have this hybrid zone that's both partially an authoritative DNS zone and also partially a discovery proxy, when do we send an answer? And so I think the answer to this is, first of all, we didn't really talk about blobbing zones together in the current document. And so we kind of need to specify that. But I think the answer to this, and tell me if this sounds dumb, Esko, is if we have 0 answers in any zone that's populated, like a DNS zone, where we don't have to wait to get the answer, then we want to wait until we either do or do not get an answer from the discovery proxy. On the other hand, if we have 1 or more answers already, then we behave the way that RFC 8766 says to behave if we have data cached, which is, it says just reply immediately, right? So I think that's the way to solve this particular question that you asked. Did I actually get the question right? Okay. Does that answer make sense?
Ted, can you relate to the mic what Esko said?
Yeah, Esko said yes, I got the question right.
In general, please go to the mic, but if it's just one word, I'll have Ted repeat it.
Yeah, so I think that sounds good. Yeah, I also proposed something like that in the email, just to kind of copy what the 8766 was already doing.
At this point, I don't even remember. I think I know what the right answer is, and I don't remember whether it was because I read your message or whether it was because I also thought the same thing. But anyway, doesn't really matter.
Yeah. So at least it means that the client does get like a partial answer. There could be more services that match the query, like if it's a PTR query, for example. But it gets only 1 or maybe 2.
Yeah, I mean, our general assumption, I think, is that if the client really wants to get a comprehensive set of answers, it should be doing DNS push, not regular DNS UDP queries. So,
yep,
yeah,
that's right.
So let's go to the next slide. I think you asked a couple more questions. Oh, actually, no. So I'm going to make you walk because it looks like I interleaved your questions with some slides. So I just wanted to talk about the discovery broker because it's relevant to this. So the idea with the discovery broker was what I just described earlier. You query for a single zone and you get answers for multiple zones. It's less work for the client. We didn't talk, the document didn't really talk about mixing answers from discovery proxies and authoritative servers, but that's not a bad thing. And so we had a little bit of a discussion about this at lunch, but basically, in order for us to support this function in the blob that is no longer an advertising proxy, there's probably an acronym to be made from that. But anyway, the blob needs to be able to do this thing that is described in the discovery broker document. Discovery broker document is a very general document, and I think what we talked about at lunch was maybe we could just like pull the bits of it that we really care about out and put them into the advertising proxy blob document, and because otherwise we're going to have to add, like, we've got a whole bunch of documents we want the working group to adopt, and having the working group adopt and having us work on yet another document is probably not a good use of time if we can get away with doing something simpler than that. So next slide. All right, so now we're getting back to Esko's question. So another question that Esko asked is like, what's the right name for this zone? Thread is using default.service.arpa, but actually that's not really even, I mean, there are a bunch of different things we might want to be able to query, right? Default.service.arpa and thread is currently being used to just say, give me any service of this type anywhere that is local.
Sorry, I'm just thinking before we jump into Esko's second question, maybe open up the floor in case other folks had further comments on the previous one. It sounds like you two were in agreement, but I just want to make sure anyone else has an opportunity.
Sure.
I'll also relay Jonathan Hui in the chat was saying press 1 to the proposed answer, immediately respond if there is an answer, otherwise wait for discovery proxy.
Okay.
So that sounds like we have agreement there. If anyone objects, please say so now. Otherwise, I think we're in good shape. We have an answer.
Yep.
All right, then sounds good. Keep going.
Okay. So back to default zones. Yeah. So there's like, this is kind of a can of worms, right? Because one thing we might want to be able to do is ask the question, is there any service of this type somewhere locally, right? That's one question. Another question we might want to be able to answer is there any service of this type on the subnet I'm on, right? My current link. And another question we might want to ask is there any service of this type on the adjacent infrastructure link if we're a stub router, if we're on a stub network? It's not clear to me that we necessarily need to be able to ask all of these questions, but these are certainly questions that occur to me that we might want to be able to ask. So I think the working group needs to do a little bit of thinking about how we want to approach this. The other thing is, so I think pretty clearly we need to have a name for this link. And that's sort of a future thing, so I don't know that we necessarily need to solve that in this document, but I'm mentioning it now because I'd like just people to be aware that that's something we need to think about. But the other thing is for SRP, suppose you have multiple stub routers that are connected to multiple stub networks that are attached to the same adjacent infrastructure link. Each of those stub networks is going to have SRP on it. One way to deal with this is to have all of the SRP updates go to a single SRP server. Another way to deal with it is to have each stub network have its own SRP data set. Currently, the SRP replication draft assumes that each stub network will have its own data set. And then the data sets could just be like sort of layered into a single zone, but then you run into name collision problems, which become difficult, and so that's probably not the right thing to do. It's probably better to have them be separate zones. And so if you're going to do that, then you need a way to figure out what the zones are called. So that was that document that we were talking about earlier that's been sort of pushed back. I don't know if we need to answer this question for the advertising proxy document, but there's a case to be made that we do. So this is just something we need to think about. I don't know the answer to that question yet, but I think we need to think about this, and I don't think we'll be ready to publish the document until we've at least either answered the question by saying, here's how you do it, or answered the question by saying, actually, we really don't need to answer this in this document. So that's that. And this was prompted by the question that Esko asked about, should we be using default.service.arpa or home.arpa or whatever. So.
Okay, yeah, I was thinking about this, what you said with multiple SRP servers, for example. Yeah, it could be that each one of them has their separate zone, let's say, for the registration. But I think there was this RFC that defines home.arpa, so it's RFC 8375. I think the way I read that, it was supposedly to mean the scope of the entire home network. I'm not sure if it's indeed practical to create something like that in home. You would need maybe a single SRP server then that is authoritative for home.arpa.
Yeah,
that could work. But I had the feeling that well, this name at least is already reserved, so it's already defined by IETF to cover, let's say, the entire home. And my neighbor can then have the same domain name, but then it should be a different zone, right? Because it's the neighbor, so it's.
Yeah, well, I mean, these are locally served zones. So in principle, your neighbor's network is not, you're not on your neighbor's network, so you're never going to ask the question, what's in home.arpa there, and so you won't run into trouble.
It would not, ideally would not conflict that way. So that, yeah, that's something that's at least defined. And what you mentioned is, yeah, also being able to do that more granularly. So if you have multiple stop networks, then you could, yeah, you could ask for services maybe on stop network 1 or 2 or both.
Mm-hmm.
And you might need new names for that. So, and I do not maybe follow what you mean with this link. Isn't that .local already defined?
Yeah, so link? But .local it generally means do the query using MDNS. And so the question is, do we want to overload it and say .local also means do the query using DNS if you're not using MDNS? And we've had discussions, you know, Stuart and I have talked about this, and it seems like maybe using .local is the right thing to do, but if so, then we need to say that. So.
Okay, and you could have something also for in identifying all the stop networks plus the adjacent infrastructure link that connects these stop networks.
Yeah, so I mean, in Thread right now, we're using default.service.arpa for that, but we aren't actually doing it in a very smart way at the moment. So for example, if you have multiple Thread networks that are connected to the same infrastructure, then it's not clear to me that those queries are actually going to do what you want. We're going to have, basically, we're going to have multiple advertising proxies with multiple Thread networks. And so the advertising proxies are probably all going to advertise the set of services that they have on the infrastructure link, which is going to be a big pile. So they are essentially going to be mashed into the .local zone in that sense. But is that really what we want to do? I don't know.
Let me just jump in. Stuart Chash from Apple, just very briefly coming to answer the previous question about whether to use .local. It's not really a difficult question, it's just one we have to answer. As currently written, RFC 6762 says very clearly, if a name ends in .local, that means you look it up with a multicast query to a particular v4 or v6 link local multicast address. We can change that. We can have an RFC updates that says, do that or the equivalent thing that gets the same answers. Or we could say, no, .local means multicast, and we have a different way to say, give us the equivalent thing.
Yep.
It's kind of a coin toss. Either one is probably fine, but we just need to decide which it is. I know you know this, but I'm answering for the benefit of everybody else in the room who wasn't in that discussion.
Yeah, I mean, one additional slight wrinkle to that discussion is that if you have a multi-link home network, then .local means a different thing depending on which link you're connected to. And in a sense, it would probably be better to have something that doesn't have a different meaning depending on which link you're connected to. That's the main argument for not using .local. Back to the question of home.arpa, you probably got a little bit of pushback from me on home.arpa, and the reason for that is because when we were working on this in HomeNet, we actually had this idea that we were going to have a multi-link home network, which we actually, you know, I mean, we came up with a sort of a solution for that, but it's not ever been, you can't buy it, and it's not clear that it's highly deployable. But essentially the idea was that each link in the home network would be a subdomain of home.arpa. And so in a sense, yes, you'd use home.arpa, but you'd subdivide it. You wouldn't just have everything all be in one big blob. The other issue with home.arpa is that it's only for homes. So if we're using this for a commercial environment, then using the name home.arpa seems wrong.
Right. Yeah.
I don't know that it's actually a problem. It just seems wrong.
Yeah, so agree with that.
Yeah.
So
David, oh, sorry.
Maybe just a question. Yeah, I was just wanted to ask the question about default.service.arpa because that's defined by the SRP draft as a kind of alias that should be mapped to something else. And I think then the question is, okay, what is this something else by default if it's not configured by an administrator or configured?
Right. So the SRP draft, I think, actually does say that default.service, it's okay to just use default.service.arpa. So, and that means that in principle, you could ask questions of default.service.arpa.
Yeah, okay, it's kind of the optional rewrites it to something else, but it's also okay to use it as is.
Yeah.
That will be the default.
Yeah, and that's kind of what we did with thread, except that we, in addition, added the meaning that if you query default.service.arpa, we do discovery proxy for you to the adjacent infrastructure link. But there isn't an IETF document that talks about that.
Okay, yeah. Good.
David Skenazy, speaking as an individual here. So yeah, I was going to say pretty much the same thing that Ted covered about home.arpa. It sounds attractive, but it comes with a whole lot of baggage that doesn't necessarily work well here. And coming up with new names is cheap. Like this is a standards track document. It needs approval from the Internet Architecture Board. I'm one of them. Like that won't be a problem.
We have an in.
For the question of potentially using .local here, I guess my question is, like anytime when we have the choice of updating and like an old RFC to reuse something or defining something new, for me the distinguishing factor is if this name shows up on an old box, what do we want to happen? Do we want it to try on the local interface, or do we want it to just say, I don't know? Or if it's something that .arpa, do we want it to send it, and in an ideal world, some box along the way will be like, oh, I know what to do with this, and we'll know that it's an old client and send that. And so my gut feeling here is what we want is the old device to send it over unicast, not only multicast on the local link. And that kind of points over .local, or maybe I'm not quite understanding what we want.
So the old device is probably just going to do a multicast DNS query.
Well, if we pick .local, yes.
Right.
But
I see what you're saying.
But if it gets a name like my printer.default.service.arpa, then it won't.
Right. Yeah. So that's a good point. And in a sense, what that means is that we already support doing legacy service discovery. Pretty much everybody supports that. Windows, Mac, Android, yeah. I think Linux also, but I'm not sure. But I mean, Android's using Linuxy things, so that sort of suggests that it does support it.
To answer your question there are Linux packages. It comes to the distribution who chooses to have it. Like a Raspberry Pi comes pre-installed with it. Some others don't.
Right. Yeah. So the other thing that's a little bit challenging about using .local is if you've got a device with multiple interfaces, then .local means a different thing on a different interface. And, we support that on the Mac and on, devices, Apple devices that have multiple interfaces by returning both the information and the interface that we got it on. But that's an additional complication.
Yeah, Eric Link, no speciality on this one. Come back on the default.service.arpa. This zone is not in the IANA registered, so thread, if it's using it, sorry, but please try to follow the procedures. And I would have advised not to use .arpa because .arpa is a real zone. So if the request leaks outside the domain, it will go to real actual DNS server that will resupport this load.
So you're going to come to the RFC 6761 BIS discussion tomorrow, right?
I guess so.
Yeah. So the reason we use default.service.arpa is because we anticipated the SRP document getting that allocation. And the way that it currently works for like home.arpa and the way we intend for it to work for default.service.arpa is that will go to the black hole servers. And so, you'll get a root query asking for, the ARPA server will get a query asking for the authoritative information about .arpa, but in principle, it should be okay. Certainly on a thread network, it's never going to escape the thread network, so you don't have to worry about it landing on the root.
A clarifying question for Eric: what's our alternative to .arpa here?
.alt. Problem with .alt is that it's a little bit funky.
We can try to go again to all the loops that we got for .local, right?
Yeah, I mean, essentially, what it sounds like you're arguing for, Eric, is the same thing that we were arguing for when we originally asked for .home. And we didn't get .home because the IAB decided that it wasn't really worth the trouble of having that argument with ICANN.
But at least at the bare minimum, right? Register this zone before it's used in actual code.
Might be too late for that one.
Good advice.
Thanks for the answer, Eric. Then it becomes a trade-off for, instead of hitting the ARPA server, you hit the root, and I think that's worse. Just to give you an example, Christian Uitma did a presentation quite a few moons ago, rightfully accusing Chrome of being the biggest botnet on the internet, because Chrome had a feature that said some random DNS queries, and it turns out it was responsible for 90% of the load on the root servers, and the root server operators were pretty mad. We turned that off. So it's a trade-off, and I think my personal take, again, no hats, would be to hit ARPA more than the root.
Okay, again, no hat. All I think is that we need to think twice, right? Yep. And register the zone before using it, but it's too late. I don't understand.
So Stuart, you should have joined the queue, but I recognize you were there before Lars. So go ahead.
You're right. I should have done. I just ran up to answer Eric's point. Absolutely right, Eric. The IANA registry exists for a reason. It's sort of an accident of history in terms of how different things progressed at different rates. If we decide to do something else, I think we can change this. We can ship software updates. So we're certainly not resistant to doing that. And you know, but I'll mention this for everybody in the room who doesn't know, there is a meeting tomorrow. It's listed on the IETF website under the side meetings, not on the main agenda. There is a meeting that Paul Hoffman has put together to discuss special use domain names and how they're allocated and managed. He has written a very short internet draft. It's only about 8 pages. So I plan to be at the meeting. Anybody else who's interested in this, please come along, because I don't know exactly what Paul is proposing. He did make it clear he wants people to have read the draft if they show up. So it's not very long, but everybody in this room has got an interest in that. I'm letting you know that's happening because, unsurprisingly, I think having names that have certain defined properties is a useful thing. That's not something everybody's always agreed on, and there'll be more discussion on that tomorrow.
And jumping in as chair to add to that, the side meeting is tomorrow from 10 to 10:30 a.m. in Richmond 6. Lars.
Thank you. Lars Lehmann from NetNode. With regards to the root name servers, the Chrome issue is rather different from what you're discussing here, I believe, because the Chrome issue was that there was any random top-level domain queries which couldn't be cached by the resolvers, which meant that there was no delegation that could take the hit. That's not the case that we're talking about here, so this is different. And the ARPA servers are, as far as I know, identical to the root name servers. So that's not taking taking the load off.
They have different names.
Different names, but not different IP addresses. It's going to hit the same machines. But in the future, we now have the option of delegating that elsewhere. But again, the random thing is the big issue. Talking about things that are either can be returned as negative answers, NX domains, which can then be cached, or even preferably a delegation that can be cached is of less concern, I would say, for at least for me as a root name server operator. I shouldn't talk for the others. But this is an ongoing discussion in several fora. So please listen in and have this talked about. And you might even want to consider having a chat around this specific general issue with the DNS Directorate.
Yep.
Thanks.
Yeah, there was actually a discussion on this very topic in DNSOP today.
Yeah. And thank you. That was really helpful.
Yep. Yes, thanks. Next slide. Yeah, we got everybody. Good. ESCO also asked the question, what about suppression of linked local addresses? Because RFC 6762 says don't. And I think the answer to that is actually straightforward. RFC 6762 is about MDNS. MDNS is single link. Link local is always valid on the local link. Therefore, suppressing it would be bad because actually you'd prefer that they use the link local address because that's not going to go away during a renumbering or something. However, in the case of the advertising proxy, link local doesn't work. And that's why that change. Looks like Esko is going to clarify his question.
Yeah, just I think the answer is clear, at least. I was thinking the same. So use the link local address because the RFC says, okay, put in all your addresses that you have, basically.
Yep.
Yeah, I think the question was more to confirm this, basically. Well, I think it's been confirmed by you now.
Yeah.
The other question is, well, what if we have some implementations around, like open source implementations that are not doing it correctly? That was thinking, oh, maybe we could kind of have some IETF push like to fix that. But I noticed the implementation I was looking at is not really maintained at the moment. So that's the bigger problem, let's say.
Yeah, well, that's something
any issues are not being fixed at all. So
yeah.
And that one is being used by lots of projects in the IoT space. So
yeah. Yeah, that's a huge problem. There's been discussion about, this is Avahi he's talking about. Yeah. There's been discussion about adding more maintainers for Avahi, and I think that's happening. Lennart Puttering is also talking about putting this functionality into systemd, which would be terrible. But hopefully, even if that does happen, the Avahi work will continue because there are people interested in it. There's like a huge number of pull requests in the Avahi GitHub repo. So there are people that are actively hacking on this. And the problem is more just getting those people to actually be able to make changes.
Just agreeing on a new place to maintain it, I think, or a way to maintain it. That's the only thing. Yeah. Okay.
Yeah. Stuart Cheshire, quick comment on this topic that comes up a lot about suppressing link local addresses or suppressing other kinds of addresses. When we're using an advertising proxy to make thread devices visible on Wi-Fi, the thread link local addresses are clearly not reachable from Wi-Fi. It's a different link. There are other use cases, like as we move into some of the stuff you're talking about of using just on pure Wi-Fi, migrating away from multicast towards more unicast, there you might be discovering things that are actually on the same link.
Yep.
So we need to think carefully. My preference is give the client all the addresses and let the client pick. I know other people have a different view, which is if we think an address might not work for the client, we should pre-filter it so the client doesn't get confused. I know there are different networking stacks, and when you're writing for some of these little embedded devices, the networking code is less sophisticated about how it handles things when it's given a list of addresses to choose. So I do see the arguments on both sides.
Yeah, I mean, I think the one thing that I would say is kind of pretty important here is to not make constrained devices do happy eyeballs. But that said, I mean, I think I agree with your basic point here. And personally, I'm inclined to say that like the SRP registrar ought to be able to handle this. But we've had discussions about this, and it sort of depends on where the SRP registrar is. If it's in a stub network router, then it knows that the update came from a particular link, and so it's pretty easy for it to decide whether or not to leave out the link local address. But let's say you've got a home router that supports SRP and is advertising it on the link. In that case, in that case, the thread border routers would actually defer to the main SRP server. There, the main SRP server doesn't really know which networks. It doesn't know for any given query whether the link local address is going to work or not, and so having it make the distinction in that case is hard. But yeah, having a constrained device make that decision is also kind of chancy. Anyway, next slide.
Hold on.
Oh, sorry.
I'm David Skenazy in the queue, no hats, just a happy eyeballs enthusiast. I think another aspect here is when you send a DNS response, you have control over the ordering of the addresses. And I think like in a scenario where like you're talking to an iPhone, the iPhone has a happy eyeball stack, and I think the iPhone would be happier to get all the addresses and just keep trying. But you're right, there's an embedded device that's not going to implement that. But what that device is going to do is most likely pick the first one. Because at the end of the day, like I was looking at 6724, how you're supposed to order your addresses. Some of it is like avoid unusable. Well, I don't know that this link local is unusable. I don't know that it's a different link. So I think we might be able to get out of it with like, your nuance bullet and, in playing with the ordering.
That's a good suggestion. Yeah, I mean, one thing to bear in mind is that it's a bit terra incognita here because we're used to MDNS doing this, and in the MDNS case, it improves things. But we don't know what it would look like in the non-MDNS case. But as you say, if we are clever about how we order things, it probably would be fine.
Hi, Ted. Mark Andrews. What we really need, and we keep coming across this, is to actually get rid of quad A and put in scoped quad A. Scoped addresses. Actually give an address, bits, and a name. And the name identifies the link. And the RA has the link name in it. And then devices can look at the RAs and filter everything, every link local address which does not match what the RA is saying is the name of this link. I've floated this a couple of times on DNS in V6 Ops, I think it was, or 6 min. But we keep coming across this problem. We can do this with A records as well. For those that, for tenor, for RFC 1918 addresses and things like that, it allows you to put your addresses in the DNS and have the end device make sensible decisions about what addresses are reachable or theoretically reachable by looking at a name. We have a method of naming things which is unique. It's called the DNS. And you assign a link, a name in the DNS, in the namespace that you have got. So for Apple, you'd have names for all your local network, something.apple. Let the administrators deal with what names to give them for the links.
So,
apple.com, but yeah, you know what I mean.
Yeah, two things about that. One is I'm not convinced that having a new record is the right solution to this. Maybe the discussion we were having earlier about how to name links was more the solution to this, at least in this case. I'm not saying that you're wrong in general, but we might be able to do something, another form of nuance, by just having the name encode the link name. The other thing, though, is that naming links is actually a really hard problem.
Mm-hmm.
So let's just be honest about that too.
I realize it's a hard problem, but we do have a way of making the namespace unique. You've got to work out how to do it within your own organization.
Well, so remember that we're talking a lot about sort of, there isn't an organization here.
But even for .home, it'd be something or other .home, and just pick a random number.
Who does that?
Let the CPE do that. The CPE is putting it out. Right.
Yeah. Okay. So this is a long discussion. I think you're probably onto something, but I don't think we should probably hash it out right now.
Yeah, I'm gonna jump in as chair. Like this sounds like an interesting proposal, but it is definitely not in scope of the DNSSD.
I realize it's not in scope for here.
Yeah.
But it's something the IETF needs to address because it keeps coming up.
That's fair, I think. But I think I'll let you sync up with our formidable AD who might be able to pick which working group would be the best place to discuss this, or a draft in dispatch.
This
perhaps,
is the price you
but-
pay for being an AD, Eric.
Yeah, but I'm gonna no. And so I'm gonna say we move on. Also, as a time check, the chair's only booked an
Yikes.
hour for this meeting this time, unfortunately. Well, because
All right. Well, let's just go then. You don't need to give us excuses. Next slide.
yeah, you have 5 minutes left.
Thanks. Okay, so basically this is a list of things that I think we need to discuss, like how are we going to do the reserved domain thing? How do we do the suppression of link local addresses? And do we do the discovery? Do we mash the discovery broker and advertising proxy documents together? I think we should probably discuss that offline given the amount of time we have. So I think that's probably my last slide. Is there more?
On that deck, that's it.
All right, then let's go to the next deck. We have 5 minutes. It should be no problem.
Challenge accepted.
Okay, this is a long deck. Actually, it's not that long. So next slide. So basically, the goal here is reliable SRP authoritative service when you don't have infrastructure support. So you don't have an authoritative DNS server. Next slide. I'm really going to rush through this because of our time. So we're assuming that SRP requesters, which is to say things that are advertising using SRP, have a way to securely identify themselves. That's part of the SRP protocol. We're assuming that any individual SRP requester at any particular time is updating exactly when SRP registrar. It might pick a different one later, but at any given time, it's only doing one. And so we can use the time of update as a way to disambiguate if we have two pieces of data about the same host, because we know it's the same host and we know what time we got the data. So the source of authority is the requester, and so we don't need to do any fancy DBMS foo. So that's basically the pitch for SRP replication. And SRP replication allows us to just completely lose an SRP server without losing the contents of the zone. As long as one server survives whatever event dropped the other one, then we're good. Next slide. So we got two documents about this. One is the SRP replication protocol. One is the MDNS TSR, terminate and stay no, wait. I don't know if anybody got that joke. So the time since registered document, which allows us to prevent temporary conflicts. Next slide. So replication protocol spec is in pretty good shape. There's been several implementations. We've had a bunch of discussion on the mailing list. I've been trying to basically treat it as a working group draft because I don't want it to feel like we're just like springing it on the working group. So it needs a bit more work, but it's in pretty good shape.
So to jump in as chair here, Ted, we had talked about this and we were waiting on like progressing the active documents before adopting this. But since we have two documents almost on the way to Eric's plate, we think the working group has the bandwidth for this one now. So, and especially like clearly there's interest. So we're probably going to hold an adoption call pretty soon.
Great.
But maybe actually I'll open in the floor briefly. If someone is opposed to adoption here, can come and explain why. Otherwise, don't worry, we'll give everyone a chance to discuss this on the list. You can keep going.
Next slide. So yeah, so there's a bunch of issues in the document. I don't think we really have time to go over them right now, but please take a look at the slide deck, and if you see these issues and they sound interesting to you, then participate on the mailing list.
Yeah, and especially when you see them, let us know if you think they're a barrier to adoption. The gut feeling I got was that there were issues that we could resolve as a working group after adoption, and that's the best place to do it. So,
yeah. One ask on this slide is it would be nice to get an early allocation for those codes.
Well, don't look at me. Look at Eric.
Oh. Yeah. Well, so I'm assuming after we adopt the document, we'll make that request. Next slide.
That sounds reasonable. The chairs can help facilitate.
Yep. So TSR, quick elevator pitch. When an SRP update happens, the SRP server publishes new data, replicates the data to the other replication peers. But before that replication has happened, a conflict occurs because we're publishing new data that conflicts with the old data, and MDNS assumes the old data is more correct than the new data, which is the exact opposite of what we want for a proxy. So the goal of TSR is to prevent these sorts of conflicts, and also to prevent conflicts when for some reason SRP replication has broken down, hopefully temporarily. And so we might actually be publishing stale data. We want to kill the stale data, not the new data. So next slide. So yeah, so the solution is just get rid of the incumbent authoritative assumption. And this is done by adding a new record per name to the MDNS message. And so if we have something that's publishing a service that is not a proxy, it just doesn't do this. And so it gets the old behavior. Only proxies get the new behavior. Next slide. We have an implementation. The document's been updated. It'd be nice to get a second implementation. And obviously, we'd really love to have people in the working group read it and see if it makes sense to them and see if they can spot any mistakes, because we certainly made mistakes in the first version of the draft. Oh my God. So therefore, we'd like the working group to adopt the document.
So first off, wow, you got through all the slides in 5 minutes. Well done. So this one, so I think we have the bandwidth as well. The only slight concern we see is that it's kind of only Apple folks on it. So we want to invite folks. If you think this topic is interesting and you'd like to, either if you've written RFCs before and you want to do it again, or you've never done it and you're interested in putting work and like learning about this, both Ted and Stuart know how to do this really well and can help give you tips. So come and talk to them after the meeting. That's what we would like to see as chairs before running an adoption call, ideally. But otherwise, I think we have the bandwidth for it, and we'll also need to check interest. Because the previous one had clear interest, this one is a bit less clear from the community outside of Apple. So that's what we would be looking for.
Cool. And it's after the meeting now, so you can talk to me right now.
Yeah. All right. Well, thank you, Ted. Sorry, folks, for running over. Thanks again for another successful DNSSD meeting. We're happy to see some documents shipping on their way to the ASG and have a flow of steady new documents coming in with like real world use cases. So thanks everyone for coming. Thanks for all the discussion. And please see you on the list and read the documents. I hear they're interesting.